folks, welcome. We're so glad you're out there today, tuned into Mathline. Hey, it's the best place to be, right? And it's the great time, all that good things. We're glad you're with us, all right? And what we need you to do is get some calls going, 844-686-2378. Give us some calls. Got operators waiting to take care of you, to pipe you in to talk to me live. That's what it's all about, helping you solve those homework problems, whatever. I'm Ernie Roberts, by the way, and I am your host for today's show. So be sure to tune us in. You got us that part. Now, call in. Again, that number, 844-686-2378. Give us your problem. We'll talk it, we'll work it, and we'll try to solve it live together on the air today. What better way to spend your afternoon, right? At least for the next 30 minutes of it. So, again, get those phones ringing. We want to hear from you. And to get you primed a little bit, let's check out today's problem of the day. Jeff is paid, a monthly salary of $3,200. That's pretty nice. Pretty nice, it seems. He will receive an 8% raise for next year. That's even nicer. What will be his new annual salary before any deductions are taken? As we all know, those deductions really make that annual salary kind of shrink a lot. All right, so what we're going to do, we are going to go for looking at this problem, okay? Why not? Let's see what we've got. Says he paid a monthly salary of $3,200. So that's important to know. That's once a month or twice a month, however he gets that amount of money total. All right. He will receive an 8% raise for the next year. Nice going, Jeff. And what is his new annual salary before deductions? A couple of ways we can look at this. All right. And both ways we should come up with the same answer. By the way, a quick shout out to our folks on Facebook, Pat, Shana, Vicky, Jason, Rhonda and Margie, all making some sort of responding, and doing all sorts of things with this answer here. And some of you got a correct answer, we're pretty sure. So let's take a look and see how we go about figuring it out. Like I said, it's one of two methods. And they're all going to involve percent, right? Everybody good on that? 8% is important, all right? So let's take a look. And we have, first of all, I like to start with this part over the base equals our percent over 100. Love to teach the proportions approach on this. And where are we starting? Well, we know Jeff gets paid $3,200. That's got to go somewhere on this. And he's going to get an 8% increase. Well, that's 8% of that base, all right? So what we're going to do is we're going to decide our base is that $3,200. That's where he started, all right? Over here on the other side, we're looking for what is 8% of that, because that's what we're going to add. We're going to add to him, okay, for each month. Now, in whatever P, X, however you like it, we're going to put a nice little simple variable in there of any sort, a letter there, and let's cross multiply. See where we're going to go. So cross multiply does not mean go across. It means go on the diagonal. So we're going to take 100 times n, which, that's easy, 100 n, right? Well, you didn't think it was going to be that easy, right? And then we'll cross multiply the other way, and that gets kind of big. But let's go to the calculator. We'll let it do it for us, okay? So we got 3,200. And let's see. We're going to multiply that by 8. And I'm getting a large number, but don't get too excited yet. That's not how much he's getting paid, all right? That's just what happens when we multiply, when we cross multiply. What's going to happen is we're going to divide by 100. Now, the nice thing is we got two zeros hanging on the end over there, and everybody goes, ooh, that is nice, isn't it? Absolutely, because here's what's going to happen. We're going to divide by 100. And some of you are already saying, oh, Ernie, you can shift the decimal. Yeah. Or you can just say, ooh, slash the zeros. They're gone. Anyway, what is that increase? And by the way, those hundreds are gone too. So n looks like what he's getting increase is $256, okay? You say, whoa, that's nice. But what we want to know is what is his new, oh my goodness, there's a word there. Got to read, don't we? We've got to read carefully. This is the kind of question you get on an ACT test. Where you find one thing, but it's going to lead you to somewhere else, all right? So here's the deal. I would look at it saying, okay, we've got, 3,200. And we're going to add 256 to that. And we get, looks like, I hope my addition's good because there's nothing to worry about here, is there, folks? So that's what he's going to get a month next year. What we'd like to do is figure out what does that come out to for 12 months. So we're going to need to take that and multiply by 12. And guess what? Calculator's going to take care of us on that. How about it? 3,456 times 12. And let's see where we go. Wow. Looks like $41,472. That's the annual salary before deductions. Now, I did say we try a second approach, all right? And what I'm going to do on this one is a little bit different. I'm still going to use the part over base equals the percent over 100. It's still going to be 8% of 100. But this time what we're going to do, we're going to look at the whole amount that he made this year. We're going to look at his annual salary, and some of you may have chosen to do it this way. So again, let's see what's the difference. Well, we've got to do 3,200 times 12 to start off with. And we're going to get, wow, big number there. 380, what? Not 380, how about 38,400? That's what he made this year. And let's put a different variable since we're going to look for the whole annual salary that he's going to get an increase, and we'll add it to that. And cross multiply this time. How about it? Let's take these two numbers together. And again, we're going to divide by 100 one more time there. So we get 100x equals to, how about it? Let's say 8 times 38,400. Ooh, I'm getting into big territory there, aren't we? So let's do it. Let's see what happens when we say 38,400 times 8. And we get a pretty big number, don't we, my friends? So we're going to write that one down. 100x equals, wow, 307,000. But keep in mind, this is for a whole year. So it's going to be bigger. That makes sense. There's a comma there. Let's divide by 100. And let's say x equals, knock the zeros off again. It looks like 3,072. Now you say, well, Ernie, what are we going to do with that? We're going to add it to, we're going to add this now to our 38,400 plus 3,072 and see, hopefully, that we come up with what we're looking for. So let's go back calculator. We got to divide by 100. Let's go ahead and do that. And we know that's what we're going to get. Now we'll add our 38,000 to that with a 400 on it too. Plus 3,072. And we end up with basically the same answer, don't we? And that's the good news. Now, which way is the better way to work it? Depends on how you're thinking. Some of you said, well, Ernie, it didn't take as much writing, it looks like there. Well, you got to remember, we spelled it out a little more intensely here, all right? It's probably about the same steps as we say, half a dozen versus six versus half a dozen of another. But they come out to the same value there. And to our Facebook folks, we had some of you that got it right. So thank you for participating. And remind you that we do have Facebook available for you all to participate on. We've put the problem of the day right after so you can like us, love us, and above all, share those problems of the day. I noticed some people were sharing, and we like that because that gets you to use that for your schools, for your friends, for other adults. I mean, it's just a great way to go. So please check us out there. Like us, love us, and share us. Those are the best things. It's www.facebook.com/Mathline online. And you might meet some people out there that are very cool, interesting folks who are participating in the same problem-solving processes that you are. And again, there's more than one way. And I can tell you there's probably even another way to go about doing that problem also. So that's what we're here on Mathline for. A lot of times everybody thinks, we got to work it one way, don't you? Not necessarily, all right? We try to give you as many options as we can. We got only so much time. Speaking of options and things, the option is give us a call, all right? 844-686-2378. We want to hear from you, our viewing audience today, all right? Get some calls. Let's have some math questions. Our operator is waiting to take care of you. They will send you into me, and we will talk live on the air. One more thing, and we'll solve your homework problems. Some of you have some homework problems. I'm surely you do. Yeah. So give us those calls, all right? We do want to hear from you. And in the meantime, while we're doing so, let's take a look at another problem here. And the simple, straightforward question, sometimes we get nervous when we see big numbers. You know, that's the first thing we notice. We don't even read what we're trying to do. So let's look at it. It says, find the greatest common factor, sometimes known as a GCF, of 225 and 300. So what are we looking for here? Well, we're going to take two numbers. And I'm going to tell you something. These are rather large, aren't they? Everybody's going, yeah, they're rather large, yeah. So let's take a look. And I'm going to take a big, long, looks like an inverted division mark. This is the way I like to do these things. We're going to take some numbers that we think are divisible into these, because they're rather large, absolutely. But there's some clues that are looking at you. There really are. So I'm taking, first of all, the fact that I have a 5 or a 0 on the end, so I know 5 is going to divide into that evenly. 5 into 300, that's easy. 5 into 225 might take a little more thinking. They will go evenly. Let's think of some more things that might go in there. 3, how about it? 3 divides into 300. 3 also divides into, you got it. It will divide right down into this one too. The 225 we have there. So, wow. So we're starting to think a little bit, right? Everybody with me out there? Get the idea? Let's go for the 5. Let's go for the 5 to start off with. And I'm going to divide by 5. And that's what we're going to do. We're going to leave the numbers out here. And we're going to divide 5 into 225. Now, I'm not going to go to the calculator. Yeah, I guess I can. Some of you may wonder, you know, what is going to happen when we divide by 5? And we want to make sure we're right. 45 is what I'm thinking in my head. That didn't like that one, did it? Let's try again. I got an error for some reason. How about that? I must have hit the wrong button there. No kidding. Let's go by 5. I don't know what I hit. Now we get a good answer. 45 is what I thought we'd have. So put a 45 down here. 5 into 300, that's easy. All right, we'll put a 60 right over there. And now, notice again, we get the same story, second verse here going on, it seems like. We have 45 and 60 with had a 0 and a 5 on the end. Same game. We can use 5 one more time. And when we divide 5 into 45, hey folks, this is why we need to know our multiplication facts, because it makes it so much easier to do the divisions here when it comes down to especially these numbers that are less than 100. So how about it? We get a 9, because that's how many times it goes in there. And let's do 5 into 60. Think your times tables or your facts, your good stuff. 5 times 12. So 12 is what we've got left over here. All of a sudden, things are starting to look a lot nicer. Now, if you'll recall, at the beginning of the problem, I said something about we looked at 5, and we also noticed that 3 would divide in there. And some of you probably wondered, Ernie, how'd you know 3 was going to go into 225 without doing it? Well, I knew 3 and 300. That didn't take much. But here, if you add those digits together, the 2 and the 2 and the 5 back there at the beginning, you see what I'm talking about? What's going on here? You have a sum of 9, and that sum is divisible by 3. That tells me if that works out, if you can add the digits, it doesn't matter what size number it is, but if you can add the digits up and they're divisible by 3, that sum is divisible by 3, then the whole number, like 225, is also divisible by 3. So anyway, so we know 3 is going to work here because there's a small number, so they're easy to look at, right? So I've got a 3, and I have a 4, because that's how many times 3 goes into 9. 3 goes into 12 4 times. And I want to go one more time, but you know what? You say, Ernie, there's nothing to divide into both. Oh, yes, there is. Divide by 1. And basically, that means we are done. That means we cannot take anything else. We can't divide anything else out. So we're going to multiply 5, 5, 3, and, 1 doesn't change anything, does it? So really, it's these 3 that are important. My goodness gracious, what we got. 5 times 5, 25. Triple that. It's 3/4, right? 75. So our GCF equals 75. Now, you divide 75 into 300, you're going to get that 4. Absolutely. If you divide 75 into 225, you're going to get the 3. You can also check back. 75 times 4 gives you 300. 75 times 3 gives you 225. I think that's a nice way to find the greatest common factor for numbers. No matter how large they get, break it down step by step by step. And then what do? Multiply these little numbers that you chose piece by piece, and then you get your GCF, your greatest common factor. So there you go, greatest common factor. Now, what's the greatest common thing we can do? Give us some calls, all right? That's what I want to hear from you guys. 844-686-2378. Middle Tennessee, Southeast Kentucky, Western North Carolina, Western Virginia, Upper East Tennessee, down here in our Central Valley area, and the Cumberland Plateau, and all the way to Nashville almost, we have you. Middle Tennessee. Give us some calls, all right? We want to help you out. That's what we're here for, is to take care of you and teach you a little bit of math, but also help you out when you have some problems and questions that you want to see worked out. So give us those calls. We'd love to hear from you today, all right? Speaking of which, while we're going for those calls again here, yes, 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 let's see what we have in a Hey Mathline going today.
Hey Mathline, this is Zoe from 8th grade in Florida. Can you convert 15/8 into a decimal and percent?
Woo, hello, Ellie. By the way, folks, while we do this Hey Mathline, remember that number, 844-686-2378. We definitely want to hear from you, all right? Give us those calls. Give us those calls. We are dying to hear from you. Now, speaking of which, Ellie has given me a convert 15/8 into a decimal and a percent. Ooh, double tasking here. Well, if we get one, we should have the other. So let's play this thing out. How are we going to do it? Now, a lot of times we see when we're converting something like 7/8 or 5/8, we ask ourselves, well, those are less than 1. How do you do that? Well, same thing here. This is greater than 1, but it doesn't come out even. If that had been a 16, Ellie, we would have been great. We'd had 2, right? And it does mean division. By the way, fractions are just division. Does everybody know that? If you didn't, you learned something right now, right? So let's look at this. So 15/8, what does that mean? Well, that means we're going to take 8 on the outside and divide it into our numerator of the fraction, which is 15. And notice I'm leaving some space because it doesn't quite work, does it? It always, you have to work a little bit at it. So let's talk about it. 8 into 15, it's going to go once, not twice, because twice takes too far, right? That takes us to 16. So I was saying, Ellie, if we had a 16 there, we'd be at 2. Problem done. Let's get some calls, all right? But as it is, we still want the calls. But let's see what we can do with working through the problem here. I'm going to toss a 0 in there because, you know, when we put a decimal in and we put a 0, that still is 15. 15.0, we may call it. 15 and 0/10. It's still 15. So we haven't changed anything. We're just adding zeros to help us solve. By the way, we said that would go one time, isn't it? Be sure you put that 1 over the 5 when you're doing this, because it's not 8 into 1, it's 8 into 15. Got it? Everybody good? So let's put that 8 under and subtract. All right. And, you know, we know 8's not going to go into 7. We planned it that way, right? Yes. So let's bring down the 0. Bring it straight down. And we're going to 70. And all of a sudden, here we got some big numbers. 8 doesn't go into 70 even either. I wish it did go evenly, but it doesn't. But we start thinking, wow, 8 into 70. If I go 9 times, I'm over the 70. I'm at 72. Not good. So let's drop down by 1. Let's put an 8 there. And 8 times 8 is going to take us to 64. Life is good again because, hey, 8 times 8 is 64. Let's subtract. We're at 6. We know 6 is less than 8. Now, some of you are starting to catch on, all right? A lot of you are catching on. I know. You watch Mathline. So let's go again. Bring another 0 down. Pull it in. We're going to play with 60 there. And keep working this thought. Now, we already know 8 times 8 gives us 64. That's too high. Let's go to 7, one below it. 7 times 8 gives us what? 56. Again, why we know our multiplication facts. They're very important. And some of you will say, we don't have to know those anymore. Yes, you do. Common Core wants you to have those, my friends. So does your math teachers, your algebra teachers of the future, all those. Those multiplication facts are so important, very important, that you can use them, work with them, and play with them, all right? And have fun with them, because once you learn them, they're fun. It's fun to know that, not have to worry, all right? We never like to worry. So now, speaking of which, while I digress, we're multiplying, right? 7 times 8, which gives us 56. Whew, still going. We got a 4. We're getting closer. One more time. Let's bring one more 0 down. See if this will make things happen. I think it will. You know why? Because 8 goes into 40. Finally, something that goes in there evenly. It will go 5 times. And 5 times 8, you got 40. My friends, we have nothing left over, and the problem basically almost finished. There's Alyssa when I need her here, all right? We're going to put that decimal straight up there, all right? Because we're going to have 1 and 875 thousandths. Remember, this is larger than 1. It's almost 2. So look at it. Does that make sense? The answer looks sensible, doesn't it? That's as a decimal, all right? 1 and 875 thousandths with a thought on the end of it. Now, let's go back over here. What do we have? 1, and there's the decimal. Now, percent is basically, we're dealing with 100 here, all right? When we go from a decimal to percent, we're going to multiply by 100. If we were going in reverse from percent back to decimal, we would divide by 100. So in other words, our decimal point shifts 2 places. And that is going to be 1 and 875 thousandths is equal as a percent to 187 and 1/2%. And there's your connection there, all right? So again, notice that decimal, move 2 places to the right in this case to get us to our percent. If we'd been given the percent and wanted to go to the decimal, we would move it in reverse, back to the left, all right? So that's your story there on that one. Ellie, thank you for doing that for us, and we appreciated Ripley's Aquarium for having us up there in the summer months to come up and shoot some of our lovely friends from other states actually there. So we appreciate that. Thank you, Ellie, and hopefully maybe you see us online there sometime, all right? Now, what we got going on, we're hoping for a call or two. Yes, 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 maybe, maybe, maybe. Please let me know if we get one, all right, guys? And how do we do that? All right, we got a phone number coming right up there. It is 844-686-2378. Want to hear from you. We want to hear from you. It's been a short week. We had Labor Day on Monday. Now, we're in the middle of the week already. We want to make sure you're giving us some calls, all right? We want to hear from you. Let's do a quick algebra problem here. And for some of you may think it's quick, and others of you may be going, oh, Ernie, I don't like those. They look like square roots. You know they are. And it says simplify. And I know what some of you are thinking, well, can we just go to the calculator and plug them in and get numbers? Well, we can get numbers, but what's the problem with those? They ramble on and on because every one of these are irrational values or irrational numbers. That means they don't come out nice and even. It can't be written as a fraction. They are not rational. Rational means you can get like 5/2, 2/5, 2/9, 7, which is 7/1. In other words, you can write 2 integers and make them work. This just ain't going to fly. You can't get these to reduce down into integer over integer form. So what we're going to do to simplify, we're going to take each of these individually and we're going to play with them. You say, we're going to play with it? Yeah. We're going to look for some perfect squares because, you know, if we had perfect square under there, if I had, let's say, 9, I could say, oh, that's 3. Square root of 9 is 3. Be nice. But unfortunately, we don't have something that's that sweet. We are somewhere between 64 and 81. Which doesn't help us any. All right, so let's work inside here. So what I'm going to do, we're going to think of some perfect squares. All right, 4 will divide into 72. We don't usually think of it very much, but it's 4 times 18. It's going to give us 72. That's a place we could start. But I say let's bump up higher. How about 9 and 8? Ooh, 9 times 8. Multiplication factor, right? Very good. That would be, 9 is a perfect square. 8 stays behind, okay? What else? Oh, how about 36. 36, wow. Divide by 2, you get 36, right? So let's start there. I always like to go for the biggest that you can get. Now, if you did 9 and 8, that's fine. It's going to give you 3 times the square root of 8, which you can break the square root of 8 down. So you say, what do you mean by breaking down? I want a perfect square times a number, all right? And I want to take the biggest perfect square I can get and pull it out, all right? So let's see what happens. The square root of 36, I'm going for 6. Pull it outside. The 2 stays behind. All right, everybody good? Now you see what we're doing? Let's play this with 18. Think about how we multiply to get 18. There's 3 and 6. Neither one of those are perfect squares. 1 and 18, well, 1's a perfect square, but it doesn't help you any. What about, oh, there's another combination. Some of you, Arnie, go for the 2 and the 9. I think the 2 and the 9 sound good. So we're going to write 9 times 2. Yep, 9 is a perfect square. What is its square root? 3. That's coming to the outside. Leave the square root of 2 behind. Are you starting to get the idea where we're going? Think, my friends, think. What can we do with our last one? Because we're getting close to a minute and a half right now in the show. So we want to hit it right. 8 and 4, some of you are thinking, yeah, 8 and 4 do, that 4 is a perfect square. Can we go higher? Divide by 2. Divide 32 by 2. What do you get? 16. That's what we're looking for. 16 times 2. So what's happening? The square root of 16, it's 4. Life is good. Square root of 2, I don't know, don't really care. It's going to ramble on and on, somewhere between 1 and 2, I guess, all right? So let's see what's going to happen. Oh, this is like having apples, apples and apples, or maybe x's, x's and x's. They're like radicals. We can put them together. We have 6 of these square roots of 2. We add 3 more. That gives us 9 of them. And then, my friends, we're going to subtract 4. And that's going to give us 5 times the square root of 2 for our simplified form there. And you know what? We don't have time to punch it in on the calculator and see if the decimals would line up. But you can do that on your own part there, all right? But again, that's how we simplify an expression. We're done at that point. Hey, thank you for tuning in today. We will be back again, live again tomorrow. We'll do specialized segments on Friday, but tomorrow's your chance to give us some calls. And you know what? As I always like to tell you, we will definitely plan to see you once again next time.